Hi, so this is my Lab 1 report, charging tape, for Physics 2212. So the main purpose in this lab was to see how charges can be changed and show that neutral objects can be given a charge and that can affect other objects by simple actions, such as peeling one piece of tape off another or taking a pen and rubbing it against your hair. We also found the amount of excess charge that can be on other objects and solidified our assumption and estimating abilities through this lab. So some fundamental physics concepts we had to understand in order to progress in this lab was force and its relation to electrical field, charge, mg, and even distance. By using these gravitational and electrical forces, we were able to correlate them to each other and eventually solve for Q, which was vital in understanding if there was excess or deficient charge and how much on a piece of tape. So going to this experiment, we found the amount of excess charge on one piece of tape that allowed the tape to float over one another, as we saw in this diagram here, or this picture here, I should say. So charging the tape, we first made our charged piece of tape by being precise with our length, as we will use this information to account for force later in the experiment. We were extremely careful to handle it, only at its edges to minimize any interference from handling it. We charged the tape by sticking two pieces of tape together and then abruptly pulling them apart. If done correctly, there would be excess charge or deficiency of charge that would be affected by the attraction to our hand. So as you can see there in the diagram, the hand will affect the U-tape if it is done correctly. So interactions with other objects. We found that two U-tapes repelled each other, which made sense as they probably had the same charge, and we also found the U-tape was attracted to a charged pen. Now this was important because we were able to infer that the U-tape is positively charged because we know the pen is negatively charged, so its attraction meant the U-tape had to have a positive charge. Estimating the amount of excess charge. We first had to find the amount of charge on one piece of tape, which we did by using the earlier found length to find the weight of the U-tape by taking the length and multiplying it times 0.1 grams, which gave us 0.2 grams multiplied by little g to get the force, which is 1.96 newtons on the tape. We then used the equation force equals the k constant times q charge squared over distance squared to solve for q. D here is the separation distance between the two pieces of tape, k constant, force, what we just calculated above. So that's that 4.43 is the amount of charge we have. Now we take this, we divide it by the amount of charge in one electron, and that is our number for the deficiency of electrons on tape B. So we also had to find the fraction of atoms accepting electrons. So an assumption we had to make is that one atom has a length of around 1 times 10 to the negative 10th, and we took that then we took the area of the tape and divided it by the length of one atom to get that many atoms on a piece of tape. We then set up a ratio of electrons accepted to number of atoms to get 7.69 times 10 to the negative 6th electrons for every one atom. So coding. Some initial conditions we had are a k constant, g, little g, gravity acceleration, and D, the separation distance between our two pieces of tape. So the coding, you can imagine, is extremely similar to what we just physically did, except we just had to write a couple of functions, such as the electric field code function that came from Lab 0 in order to calculate what we needed to calculate. So here is a picture of what was made, and we got the charge to be different from what we physically found. Obviously there are some scopes of error as we're physically doing this because of, say, how we were handling it and other factors. So one assumption we made is treating the long tape as one concentrated point in order to make the math easier on us, and yeah, some differences between the model and the actual experiment because there will be sources of human error. So even if electrons and protons switch charges, we would find that the general numbers remain the same, and so would their interactions. The only thing that would change is technically the sign on the numbers, but say the U-tape would be negatively charged, but the pen would also switch charge, so their attraction would remain unchanged. They're still attracted nevertheless. And as I stressed earlier, it's important to handle the charged tape carefully and avoid touching it as much as possible, because the more we touched it, the more we took away the excess charge that was built on the U-tape, or in this case, we may have replenished the deficient electrons on the tape. So in conclusion, our model and actual lab had differing values, but they were both helpful in understanding the core concepts behind this lab. So yes, yep. Thank you.